Okay, in this video, I'm going to show you how to solve for a portion of a roller coaster problem using the conservation of energy. So, in order to use the conservation of energy, you kind of need to know what the conservation of energy stands for or tells us or what it is. So, the conservation of energy basically tells us that energy stays the same. Well, not just energy, but total energy stays the same from beginning to end. Okay, so the conservation of energy states that total energy stays the same from beginning to end, unless there is an outside force. That outside force could be friction, it could be air resistance, it could be an outside applied force, but really any other type of force. So it's always going to stay the same. So basically, key thing, total energy is what stays constant. Okay, so we're going to use this to help us solve for the first part of this roller coaster problem. So for the first part of this roller coaster problem, we know that the height is 2 meters. We also know that the roller coaster is traveling at 1 meter per second. So this is key information. We know that it has a height and it has a velocity. So because of these two things, we know that they're going to both be potential and kinetic energy. So our height is 2 meters. So with height, I know that I can solve for the potential energy of this object or of the roller coaster. So my potential energy, I'm going to take my mass, which is 10 kilograms, times 9.8, and my height is 2 meters. So I'm going to plug this all into my calculator. 10 times 9.8 times 2 gives me a potential energy of 196 joules. So that is my potential energy up here, 196. Okay, next I'm going to figure out my kinetic energy because I do know that I have a velocity, so I can solve for the kinetic energy of this object. So Ke equals 1/2 mv squared. My kinetic energy is equal to 0.5 times my mass of 10 times 1 squared. So 1 squared is 1, times 10 is 10, and half of 10 is 5. So I know that my kinetic energy is 5 joules. Okay, so I know that my potential energy is 196. I know my kinetic energy is 5 joules. Well, that means my total energy is the sum of potential plus kinetic. So my potential energy is 196 plus my kinetic is 5. That gives me 201 joules of total energy. Okay, so the only thing that I know that can remain the same throughout this roller coaster is my total energy. So I'm not going to solve for any more of this roller coaster problem, but if I did move on to part 2 of the roller coaster, the only thing that's going to remain the same is my total energy of 201 joules. That will remain the same throughout this entire roller coaster. I can't assume that the velocity stays the same because it's going uphill, it's going downhill. The height obviously is not staying the same because that's changing from 10 to 5 to 0 to 7. The only thing that I can assume that I can transfer from one part of the roller coaster to the other is my total energy.